So we are up and running also on YouTube, and the recording has started. So thank you everyone for joining us today. This afternoon we have together with us the colleagues for Trend Micro, Bharat and Mihai. And they are going to talk to us about mitigating risk and threats in the cloud, and also express some use cases and demos in this respect. And I hand over to Bharat to make a short introduction about himself and to continue the presentation. Thank you for participating.
Thank you, Marissa, and thank you for the invite to present to the local chapter in Romania on this topic. Yeah, my name is Bharat Mistry. I am the technical director here in the UK. So I run the solution engineering team. We're very much a customer-facing team, looking at customer problems, and then really developing or crafting a cyber solution based on our technology for customer needs. I've been with Trend Micro close to 9.5 years. I started off as a sales engineer, progressed to a strategist, and then in the last 3 years, I've been running what we call the solution engineering and the customer service management team. My background is, prior to joining Trend, I was at Hewlett Packard as a consultant working in the cybersecurity arena. And really kind of doing security transformation. And that's kind of what I do at Trend as well. And that kind of really nicely fits into what we're going to talk about today. Certainly over the last, I would say, 5 years, and more so in the UK, we've been leading the charge around cloud adoption. And I've been working with a lot of enterprise customers how to make that journey seamless. And really risk-free where possible. But really to understand the kind of risks and threats that we do see in the cloud, we need to understand some of the core problems that we're facing out there right now. And before I kind of go into the main presentation, I'll just quickly start the scene off. Over the last few years, and I suppose in 2023, we saw a huge surge in cyber attacks. And really, the dial is changing. We're seeing more and more really transitioning to the cloud. We've seen traditional on-premise attacks, but more and more is going to the cloud. And even cloud providers themselves are now targets. Certainly last year, if you look, Microsoft were hit on the Azure platform. There was the Google ransomware attack. There was also the AWS attack as well. So you can see that there are a number of things going on. And over the next 30 minutes, what we're going to look at is a couple of things. First is, why is it important to secure the cloud? We'll certainly look at the risks and the threats. And then secondly, look at the strategies to help us evolve in that space. So kicking that off, if we look at how organizations have transformed, really when I look at any company now, they are becoming a technology company. It doesn't matter what you do, whether you are a high-tech manufacturer or whether you make boxes, right? You are ultimately a technology company because customers are demanding that 24/7 access. They want to use mobile applications to transact with you as an organization. And what we're seeing is that all companies in all verticals are using cloud as a platform for digital transformation. And we're certainly in the UK, and I think this we'll see the same shift happening throughout Europe, is companies will be more and more reliant on public cloud services. Certainly when you look at the agility that it offers, and it's all driven by global demand. When you look at, the innovation that cloud can bring, how it can change a business, the kind of new business models you can drive very quickly, you can see why cloud is a very prevalent platform. But with that comes some inherent risk. And really, we need to be in a position where organizations really need to think about assessing the risk in the cloud in order to really identify the threats and mitigate or reduce the risk where possible. with that kind of goal of protecting the sensitive data that we all hold. We're seeing some of the data shift from on-premise and into the cloud. And the thing is that that data is now distributed. And really more important than anything else, it's ensuring that we maintain compliance. You know, if you're in critical national infrastructure or anything like that, then you've got to have compliance regime that you need to adhere to, like NIS2 and things. And that kind of leads on the back of things like ensuring trust with really customers and shareholders. And here you can see some of the risks that we've seen. You know, we did a survey last year, and nearly all organizations have suffered some kind of attack in the cloud. And you can see the common causes. The biggest one by far is the misconfiguration. And you think, well, how is that possible? Well, it's easy. When you see an organization under pressure, you see a developer who is being put under pressure to get new services, new applications, new features out. They just want to push from dev into production very quickly. Very little thought has been thought about the configuration. Sometimes we see, I've seen instances where things like secret keys have been pushed out into the cloud. And these are absolutely vital because if these keys or credentials are accessed by third parties, they basically own your cloud account. They can do whatever they want. We've seen things like misuse of cloud privileges, and we've seen things like 0 days being used as well because of the patching regime. And we'll look into why some of that happens in a minute. By the way, if you've got any questions, please put them in the chat window and I'll answer them as we're going along. So, and really, this was an independent survey done by ESG last year, that Trend Commission. 1 in 3 businesses have difficulty seeing the threats in public cloud data. And the reason for that is because that wide dispersal of data, when you look at some cloud services, if we look at Amazon alone, you've got 3 different types of storage available. You've got S3 buckets, you've got online storage, you've got archival storage, and then you've got storage in applications as well. So you can see why the what the scope is, and this kind of slow response widens the breach aperture. What we mean by that is when we do see a breach, actually by the time an organization has seen it, it's so late that the data has already been exfiltrated and used somewhere else. And in most cases, it's normally an outside entity. So it could be a government agency that might be telling you you've been breached and you've got to do something. We saw that in the UK where the NCSE told quite a few high-profile organizations that they were being targeted because they could see traffic going out. So you can see what happens. And really, when we look at it, securing data in the cloud is complex. It's complex for a number of different reasons. The primary reason is really, where do you collect the logs from? When you're on premise, you kind of know the systems you have. You would correlate to some degree. You would have, maybe a SIM or a log collector. But when you start using public cloud services, all of a sudden you've got different places to then pick up those logs, different audit trails, different events, different parameters to look at. And that also leads to the second point around the strength of the detection models. These are the threat models or use cases we want to see. They're not always known. And the question is, how quickly can you adapt? And it's that kind of hybrid working environment, unless you were born in the cloud company. So what I mean by that is, if you're a new organization and you don't have any legacy debt and you start in the cloud, the chances are you're going to have some kind of on-premise element and you're going to have some kind of public cloud element. The thing is, how do you kind of coordinate between the two of them? And then the last bit is really understanding that kind of attack surface. And it's all kind of, when you put it all together, there are a number of different other elements that are more fundamental than that. I think the root cause in many cases is the cloud is very dynamic. You spin up, you spin down. The question is, how do you keep track of those services as they spin up, they spin down? Still, to date, the biggest number one issue is the shared responsibility model. I don't know if you guys are aware of that, but this is understanding actually in a public cloud environment what the cloud provider will do and what you as a customer of that is responsible for. Certainly in the UK, when we first started taking out, seeing customers going out to the cloud, they thought the cloud provider would provide or take care of the security for everything. Well, that could never happen really because they don't own the data, you do. So there's an element of responsibility you have around safeguarding that data. And the question then becomes is, do you have to understand what your cloud provider is providing you and understanding whether is this acceptable for my risk level or do I need to do something else on top? And I'm just talking at a data level, but there are other elements to this. If we take it down to its kind of fundamental element of, let's say, virtual machines, well, who patches the virtual machines? Who will look after the operating system? Who patches the applications? And this all depends on the service model that you take, whether you do infrastructure as a service, platform as a service, or software as a service. But ultimately, you're still responsible for the data, right? So you can see there are a number of different elements that come into play. And this kind of leads to this point here. When we go out to the cloud, and I've seen a lot of organizations in the UK fall foul of this, they've thought that the on-premise models that they have for security, and what I mean by models, I'm talking about the technology, the people, the process, but also the culture has a big impact. There was a big manufacturer in the UK that we were talking to, and they wanted to take things like their on-premise, let's say, checkpoint firewalls into the cloud, and they just thought they could lift and shift that technology and then use the same processes. But as you know, you can't take a physical appliance and put it in the cloud. You've got to do something a bit differently. You've got to use a software appliance, and then when you do use a software appliance, you've got to think about, well, at a ground level, how do we route traffic into there? How do we inspect it? Then how do we get the alerts out there and sync it back with everything that we have? And so what this organization did was they very quickly realized actually we need to have a separate tool chain for the cloud as to what we have on premise. So now you've got duplication of tools, duplication of processes, highly inefficient. It doesn't make sense. What you need is really an adaptive strategy that can kind of take care of that. And I think this is where the first real reality kicks in, is that it doesn't matter where you are in the cloud, there is inherent risk when you take on cloud services. And it's recognizing and understanding what those risks are going to be. When we look at, we'll look at a typical cloud journey in a second, but the minute you outsource, it's like having a third-party supply chain. The minute you let things out of, let go of out of your own kind of realm of control, I would say, there is inherent risk in that platform. And it's a question of how do you, A, understand the risk, B, quantify it, and then what do you do around mitigating or reducing it, or do you accept it? So this is a typical kind of cloud journey we see, right? On the left-hand side, certainly from about 5 years ago, a lot of UK organizations were doing this, and we're starting to see some of it in Europe, where people were taking, some legacy or data center low priority applications and moving them in the cloud, seeing how they work, seeing how they develop, trying to use it as a learning ground. And then as you kind of gain confidence in that and you understand, actually, we know how the cloud works better. We're getting used to this mindset change from doing manual to automation. And what I mean by that is when you provision services on premise, there's an element of manual play involved. Whereas in the cloud, you'll be using things like infrastructure as code. Very dynamic, being able to spin up, spin down. As you gain confidence in that, you then start to kind of move away from infrastructure as a service and start moving up the stack. And we see A lot of organizations using things like microservices with containers, using cloud file storage, kind of using serverless, and really using cloud native services. What we're seeing now in the UK is something quite interesting. Rather than being aligned to one cloud vendor, we're seeing multiple cloud vendors. So typically, certainly when we first started, some organizations were using, for example, AWS for their Linux workloads and Microsoft Azure for their Windows workloads. What we're seeing now is application usage being flipped between the two. One thing that's interestingly happening right now in the UK is some organizations are starting to see their cloud costs explode. And so they're looking to come back on premise, but not in the traditional way. They're looking to come back with a private cloud offering. So now you've got kind of three offerings. You have on-premise, legacy, you have public cloud services with maybe AWS, Azure, or Google, and then you might even have a private cloud with another provider. And the question you can see, risk is all over the place. And the other thing is, the more of these services you use, the more complex it's going to be. And with that additional complexity, you're going to introduce more risk. Hope that kind of makes sense. And it really boils down to this. Security has to keep pace with the innovation that cloud providers are providing. And that's the name of the game when it comes to security. Traditionally, on-premise, security has always been seen as a blocker, or certainly the last person in the chain. And this goes back to what I said, a few minutes ago around the culture change. We have to see security as a proactive mechanism that's not a blocker that has to keep change. And I'll give an example, right? In an organization that's going cloud-centric, developers are now under more pressure than ever to develop new functions, new features, drive innovation to keep up with market pace, which is driven by the business units. And so they're making changes. They're making daily changes to infrastructure services, to applications, and deploying to production multiple times a day, potentially. Now, if security is a block to that, it just stops. Then the net effect is they're going to bypass those controls and they're going to do what they need to do. So this is where shadow IT kind of typically spawns from, but we can see the problems that come with it. And it's coming from, I've talked about developers, but reality is that this is coming from all directions. We cannot just slow this process down. And to give you an example, this is just a list of some of the services that were launched by AWS at reInvent last year. And this is not a one-off. This is something that's done multiple times per year. Typically, when we see new services from a vendor, they might come out, maybe 8 to 12 months at a time. But what we're seeing now, every quarter, there are new services, new innovations coming out. And the chances are that your organization is going to want to use them. The problem is how, with these new services, what inherent security risks do they bring? And how do you keep pace with knowing that whatever service is being using, what exposure does it bring from a security element in terms of maybe a compliance violation, maybe it goes against something else, maybe it's open to something else. We need to have a real-time view as to what's going on. And really, the only way to tackle this is you need a real-time approach to security. There's no other way around it. This is a given. Real-time assessment is non-negotiable. You have to be able to respond and to understand the risks as they're happening if you want to keep pace. The question is, and this is where the crux of the problem is, how do you do that? How do you actually keep pace? Well, there are a number of things we need to kind of look at. Really, it's all about on a continuous basis. You need to think about the following things. Number one is you need to inventory and dynamically assess the risk scoring for all your assets. Because if we do this right, we can improve visibility and prioritization. But there are a few things we need to do to kind of tackle this, right? The first is you need to really understand what resources you're using. All the different pieces of infrastructure, services that you're using in the cloud. You need to get a view of where they are. Secondly, on top of that, you need to really understand the configuration of the infrastructure and the services that are being used. I'm not on about at a functional level. I'm talking at a security configuration level to see, are there any weaknesses in the services that are being used and really how it's been set up. Once you get an idea of this, you then need to layer your applications on top of that. And what we're looking to do is to really understand how those applications are using those underlying services. Now, those applications could be developed in-house, or they could be third-party developed. And there could be a number of different things that sit underneath there. It could be virtual machines, it could be serverless, it could be containers. What we really need to do is understand the relationship and the connectivity between the application, the cloud native services, and the infrastructure that's being used behind them. The next thing on top of that is we need to understand, certainly for applications that are going to be external facing, is how are the external facing elements configured. So I'm talking about things like API gateways or internet gateways. Have they been configured correctly? What risk, do they pose? Have we put in mitigating controls to limit the exposure in terms of who can get in, who can connect, how they connect, and the interactions that they have? Because when you put all these things together, they then kind of help you understand the impact on your kind of compliance regime, because you're going to have some kind of compliance mandate to run the business, right? So these are kind of 4 areas we need to think about in terms of concepts. I suppose the next bit is, how do we kind of tackle that? and really, I suppose we need to change our mindset thinking. And you need, I would say, a modern toolkit. And what I mean by a toolkit, I'm really talking about not just the technology, I'm talking about the people, process, and culture that sits behind it. And over the next few slides, I'm going to talk about some of the strategies and then kind of a framework as well. But certainly at Trend, the way we've kind of taken the approach and the best practice we do around this is based on 3 broad pillars that we see. And the first pillar really evolves around looking at everything that you have, looking at all those bits of infrastructure, looking at all the cloud accounts, looking at all parts of the applications. So this is APIs, gateways, etc., and pulling this information together so you have an idea of your risk view. In Trend terms, we call this attack surface risk management, right? So what we're trying to do is give you a holistic view of what your cloud infrastructure looks like. And what we're trying to map that back to is a kind of a risk and a governance view to help your compliance regimes. This gives you your proactive view as to what the exposure looks like. Because if you can see the exposure, you can start thinking about, well, I can start mitigating some of the threats already before they actually happen. And if we think about it in traditional information security risk management terms, this is the risk assessment phase. When you do your threat modeling, you understand the exposure, you then start thinking about the risk treatment behind it. Do I mitigate the risk? Do I reduce it? Do I accept it? Or do I transfer it? The second pillar is all around that detection and response. Now that we've got a view of what our infrastructure looks like, now let's look to see how it's being used. Actually, what's happening in your infrastructure on a day-to-day basis? Let's have a look at the events, the actions, the alarms. Let's determine what does good look like and what does something suspicious look like. Because when we do see something suspicious, we want to be able to act on that and act on that very quickly to be able to respond, well, to be able to detect and then be able to respond. And that response could be isolation, it could be termination, it could be whatever response action we want to take. And then the last piece, and this is really the cornerstone, is we need that real-time protection. Right? So these are the traditional controls. When we think about security, these are the technology controls that we would put in play. So these are controls like firewalling, like intrusion prevention, like anti-malware protection, and things like that, web application firewalls. These are the kind of core capabilities. So what we're doing is we're building up I would say a platform-based view already. So we can see the three pillars here. Let's kind of dive into this and understand how do these three pillars actually work together. If we take this circle as your attack surface, this is the complete attack surface that you've got. Our first bit, the protection layer, the last bit that I talked about, comprises of capabilities like, your SIM platform, your email protection, your EPP, your IPS, your proxies. And they consume a part of that attack surface, right? So, but you've still got a big differential left. If we think about our detection and response side, we have capabilities like EDR, NDR, XDR, IT, DDR. There's lots of these DR type things coming, right? And I'll talk about two more of them as we go along. But again, these will then further take more of your attack surface up. But there is still a big gap in terms of what do I do? So the next piece, and I briefly mentioned it on the last slide, called attack surface risk management, talks about that exposure management that we have. And so if you look at the first two circles, they're predominantly used during an attack. These are the reactive phases that you'd normally have. So this is what we do day to day. Certainly, when I look at maturity of organizations, kind of, SecOps platforms, this is where they are now. But really what we want to do is we want to get on the front foot before the attack, be proactive, try and reduce the risk or the window of opportunity for an attacker to get in where possible before anything happens. And you can see with these first three circles alone, we've reduced that attack surface significantly. The thing is, you're never going to completely cover the attack surface, right? There is always going to be what we call residual risk. The question is, can you make that residual risk small as possible? And it's about having a strategy that sits around those three pillars. So I'm hoping that makes sense. The three pillars that I talked about at Trend, around ASRM, around detection, response, and protection, this is how they work in conjunction with each other. So let's put a bit more kind of meat on the bones, right? And one of the areas I talked about was, how do you bring everything together and understand some of the relationships with them? So the first part is really around what we call asset graph. And what the asset graph allows you to do is to really establish visibility of those resources, but more importantly, the connectivity or the relationship between them. This is absolutely key because in the cloud, this is difficult to see. Here we can see we've got an EC2 instance. It's mapped to a volume. It's connected to a VPC. There's an administrator group attached to it. There are a couple of IAM roles and there's a database attached to it. Having this picture significantly changes the mindset that you have. Because what we now try to do is saying, actually, we understand what the visual points are. If we can understand the exposure points around that, we can then start to think about something called predictive attack analysis. So understanding how an attacker might think. So we've got the asset graph, we can see that. We then have this secondary capability called predictive attack path analysis. So it's taking that picture and actually drawing a picture as to how an attacker might move from one resource to another. So based on that last example, here's another example that we can see. Here we can see from the internet, we've got VPC gateway that routes to a VPC. That in turn leads to another area which then maps onto our EC2 instance, and then an IAM role, and then the RDS instance in the background. So we know if we had an exposed interface, an API or an EC2 instance in that external VPC gateway, we know that we could quite easily traverse through into an internet-facing VPC, which would then route into an EC2 instance, and then ultimately back to the crown jewels that we have in that RDS database. The thing is, when you map things out this way, you can then start to create playbooks and automation around these kind of use cases. If I think about what people have done in the past, they've had to build them up based on experience. After an attack has occurred, oh yeah, this is what happened, and then we build a use case around it. When you can visualize it like this, you can automatically start putting some playbooks around it and saying, if I see a non-authorized IAM role, for example, trying to do something, I will give it so many attempts and then I'll cut it down, or I will take some other form of action behind it. The third element is all around the data. Data is really I would say, the lifeblood of any organization. And when we move to the cloud, what we're now doing is making a change here. Because what we don't want to do is take those legacy methods of scanning things like file data that we're ingesting in, especially if that data is taken from unknown sources. So I'll give an example, right? So I was talking to a customer that were trying to move to an online platform for their insurance and banking system. And normally what they would do is when someone applies for a new bank account or a new insurance policy, they would have to go to a branch and present their credentials, their driving license or whatever. Or if they were making a claim, they'd have to show evidence of what was going on, and this would take time. So what this insurance company wanted to do, and you might get this in kind of Romania as well, is they wanted people to use their mobile phones to take a photograph and upload straight away directly onto the platform so the claim could be processed or account can be created. Changing the business model completely from going from Monday to Friday 9 to 5 to being 24/7, anytime, any place, anywhere access. Problem is you're taking in data from unknown sources, and that opens a playground of saying, actually, this data, do we know it's malicious? Especially if it's file data, if it's for example, an image that's captured on a phone. We know with stenography, for example, you can hide code in there. You can make things malicious that on the face of it don't look malicious. The question is, you need some cloud native capability to be able to scan and do the downstream traction on the back of that. So what we see here is, someone is uploading some data. As it comes in, we need that ability to agentlessly scan that data as it's traversing. So again, security not getting in the way is actively helping that pipeline go through or the upload go through. Give some assurance that the data is good and pass it on to downstream processes. If the data is bad or malicious in any way, let's quarantine it and do something else with it and have a separate workflow. Either way, what you're not doing is you're not interrupting with the business. You're not interrupting with the flow of what's being asked. You're not having to stand up additional infrastructure on top of what your core business needs here to do the scanning. Likewise, we're looking at the data. There is a new concept coming out around what we call data security posture management. And this is really all to do with identifying your data and monitoring the risk around it. So what we mean by that is, how is that data moving around? We're not looking to see what changes are being made, but we're looking to see who touches that data and how is that data moving. It could have started off in an S3 bucket. All of a sudden, it's traversed to a online file system, which may have then gone to a database, which then somebody else is touching who shouldn't have touched it. The thing is, when we see multiples of these things happening, and we know the data's being tagged in a certain way, we can start applying a score around it, and we can start tracking that score, and we can start layering identity information on top of that, because we know identity and data normally go hand in hand. And when we think of identity, we think of as people, but in the cloud world, identity could be a machine as well. So we have a lot of machine-to-machine interaction going on. And it's knowing what those machines doing with that data and how they're manipulating it. So that kind of leads us on to this second bit, is around what we call cloud infrastructure entitlement management. This is really about identifying what an identity can do in the realms of access on the infrastructure. In old world, this would be things like your AAA services. If you've ever used Radius, your access, your authorization, your auditing. But this is stepped up a level, and you want to do this in the cloud. And again, here we can see, based on identity, we can start to assign some, I would say, risk events against it. Has the password been changed? Has it been sent around? Have we seen unusual application access based on that identity? Do we have multi-factor kind of associated with it? What I'm trying to get at is, normally you do things in isolation. What we're trying to do is we're trying to bring all of these things together to give you more of a unified view. And that's what you need to do in the cloud. I talked about it early on when I said you need to understand all the parts of your infrastructure, all the services that you use, all the applications that you use, and how they're touched. These are the capabilities that start bringing all of that together. And really, that kind of takes us on to this last bit here. There's an industry term going around CNAP. And CNAP has different things it means different things to different people, but ultimately it's that process that goes really all the way from development or right at the beginning of the chain or the pipeline, all the way through the various phases where you do your code build, your staging, your pre-prod testing, and rolling into production, and then kind of ongoing monitoring. CNAP covers all those phases, but in a manner. And what we're trying to do here is really understand all aspects of the risk that are introduced along those chains. But more importantly, is you need capability that kind of sits across that outer rim. So you need the ability to do things like third-party integration. You need the hybrid support. You need those core SecOps capabilities around forensics, detection, response. They all come together. These are just some of the things that you may want to think about when you're starting to think about, really, how do I do security in the cloud, and how do I start to mitigate them? Here's an example of how Trend would do it. Again, going back to those 3 layers that I talked about, those 3 pillars. At the bottom, we can see, again, this is based on AWS, but this could quite easily apply to Microsoft Azure or to Google Cloud. We have that protection layer. And when we see in Mihai's demo, you'll see some of this come through. We'll see the capability to protect virtual machines, the ability to protect things like, S3 buckets or, cloud file storage, looking at things like microservices. On top of that, the XDR capability, we can then start looking at the detection response, actually ingesting the telemetry from these sources, correlating them, putting them into what we call observed attack techniques and into workbenches. So taking what could be hundreds and thousands of alerts, narrowing down to about maybe 10 things that you want to look at, and then kind of responding on the back of that. And then sitting on top of that is the attack surface. What do I have? What does the exposure look like? And where do I need to start focusing my energy? And really, what I really wanted to kind of give as a takeaway was, there's a surge in cyber attacks targeting public cloud services. I mentioned some of them, and we're going to see more and more of that in 2024. Certainly, when we look at things like crypto mining happening, we see denial of service happening, we see takeovers happening, we're seeing ransomware happening. Cloud is a new playground for that. And really, the primary reason for that is on this third point. It's around the misconfigurations. They're so easy to do. It's so easily done because it's a new way of working. And that goes to that second point. Each kind of stage of the cloud has some inherent risk. And the question is, how do you identify the risk and how do you manage it? Now, the last piece is you could do this in isolation. So you can take a patchwork quilt or do it as a jigsaw format whereby you do your own, but it will take time to do. Or you can take a platform-based approach to security and lay a risk on top of that. In which case, you will focus your energy in the areas that are critical, will give you an outcome that reduces the risk and certainly reduces things like your mean time to detect and respond. And really, that was it from me. I don't know if there are any questions out there, but open to take questions.
Thank you. Very interesting, and let's say a good oversight of the main challenges, and also thank you for the insights from the UK market. This is very useful for us. I have a couple of questions.
Okay.
I wanted to ask you, in this multi-cloud scenario, do you see that it's easy to create an overview of risks by obtaining data from the multiple clouds that are used by a company? Is this something that is easy to do and bring into those dashboards that you seen you showed earlier?
So you need really you need something that's going to be platform based that can ingest into a single data lake. The key to it is having a single data lake. If you can do that, you can start mapping telemetry into the data lake and then using common models to get a holistic view across all the different clouds. I've seen organizations trying to do it step by step, and yeah, you can do some of it, but the problem is each cloud provider will give you different information and they're not consistent. So AWS will give you, let's say, some certifications around, ISA or whatever their SOC standard is. Azure will give you something similar, but it's not in the same format. The problem is you can't assess, you can't take a pen tester or an auditor and go into their data center and do that audit. So you don't know. So you're kind of reliant on them. The other problem is when you do things like that, it's expensive. And so you've got to do it on a one-time basis. You might be able to do it half yearly to assess the risk. But because of the dynamic nature of the cloud, you have to do it in real time. You have to do it near real time to get a true picture of what's going on, because things go spinning up, spinning down, and you need to get a picture. And that's where the challenge comes in. So it has to be a platform that natively integrates with cloud providers, can normalize the data across different providers in a way that makes sense, and then presents it in a way that really resonates with different audiences. So is it with SecOps? Is it with risk? Is it with board members?
Thank you. And I had one more question about that file security that you mentioned. So when files are uploaded, I know, by clients onto the platform of an organization, in terms of the real-time analysis and response, do you view this like a service that is called by the APIs created by the company. When first they have a new service, they create the software and they just call for this service to scan the files and so on and receive those responses. So this is how they should be embedded, or some other way.
It's both. It's both. So I can talk about it from a trend perspective. When we started this journey probably 5 years ago, that insurance use case I talked about, we were asked about that, and the only way forward at that time was to stand up a virtual machine to mount the file system to scan it. It's just too cumbersome. So you need something that's going to be cloud native. And what we started on the AWS platform, for example, was we realized that customers wanted to keep the data local. So we came up with a capability to scan S3 buckets, but within your own tenant or within your own VPC. So that was one way of doing it, and that works pretty well. What we then saw was a more maturity around there, and actually our customers were saying we don't necessarily want to put it into an S3 bucket, but we want the ability for the application as the file's being ingested to be able to do the scan. And so we came out with this secondary capability of offering an API service. So it's an API capability that's available that you embed onto the application, but it'll make an API call in our in Trend's instance to a Trend instance, do the scan and check, and you'll get a validation back. The thing is, you need something that's probably both, depending on the use cases you want to cover.
Yeah. I was thinking also from the point of view of business, how much time the scanning takes in order to keep the users in a particular window, like waiting for upload or something like that. So from a user experience perspective.
The scanning is pretty quick. We don't need to see the whole file. That's the thing, right? If there's going to be any malicious code, it's more than likely to be in the headers, because that's where the damage normally occurs. So we only need to see the first part of it. That's more than enough to kind of give a quick assessment. And this is where you need multiple controls, right? So this is your first stage control. If that file, let's say there was something embedded right in very deep that we couldn't catch straight away on the workload, then you would have some kind of anti-malware capability that would then look at as the file lands, as you then do some pre-execution machine learning around it, and then maybe do some memory-based machine learning to see what's going on as well. So it is having a layered approach to security and knowing what to apply when.
Okay, super. Thank you for your response, and thank you again for the great presentation.
Thank you.
And now we hand over to Mihai for the demo part.
Can you hear me well?
Yes.
Okay, so let me start and share my screen. Just a second to prepare. I was doing some tests. Where is it? Share. I think this should be the one. Can you confirm that you see my screen?
Yes, we can see it.
Okay, so first of all, thank you very much, Larissa, for inviting us. First, I will present myself. So my name is Mihai Shari. I am leading the tech bench for Central and Eastern Europe. I have quite a few experience in IT, especially in the last, I think, 10 years. I'm mainly doing cybersecurity in different roles. So thank you, Bharat, for your presentation. That was very interesting. I will continue showing a bit on our platform, which is called Trend Micro Vision One, Trend Vision One. Of course, we have being a platform approach. It will take us, I don't know, maybe too much time. So I will try to really focus on the things that are related to cloud risk cloud operations, cloud excellence. So whatever it's is related to the cloud. So I will start with the main part. Yeah. So the part where every CISO or every governments or every even IT should look when they are looking, to understand what's happening in their environment. An environment for us means basically many things, many aspects. First is the devices, and by devices we understand either servers, computers, even mobile devices. So whatever electronic device that has an operating system, that has an IP address, and it communicates over the network. And here we do many things. We do inventory of the applications. We do vulnerability assessment. So with those, we calculate the risk. Yeah? This is, let's say, the on-prem part. Then we have another part, which is also very important, which is the internet-facing assets. Internet-facing assets, what we do here, we just take the external domain of the company and we do an image. So we do crawl on those domain and IP associated, and we tell with a good confidence what is your image, so what is your exposure to the internet. Then we do accounts because so usually, the user is the weakest link in this cybersecurity defense. So here we take in consideration all the aspects that goes to assessing and putting the risk on users, applications. So this is the services cloud services that are used by our internal. And now reaching to the point of our discussion, we saw some slides on Bharat's presentation about the cloud assets. Yeah? And how we do it here is basically quite simple, because using these cloud services, it's different than we were using on-prem. Yeah? Everything in cloud, it's API based. Usually there are no agents. It's not easy to deploy agents on, I don't know, serverless functions like Lambda or even in containers. Yeah, it's not easy. So this is why the industry had to reinvented themselves and using cloud native technologies. And for that, we, as you were asking, Larissa, and this is what I'm also supporting or in favor of such tools where you can integrate multiple cloud platforms. Of course, you have the big benefit of using, I don't know, AWS or Google, but on the other hand, you can left to be captive, to a cloud vendor, and then that things to do. So of course, every cloud vendor have their own security tooling, and what we do basically here, especially with AWS, we go and integrate with those. But the downside of using, for example, AWS Controls Tower is just AWS, and as I was stating before here, we very easily can integrate. So we just give a name, description, and just then select whatever functions we want to monitor. So we can do, okay, this is the core feature. Then we can do agentless vulnerability threat detection. We can do real-time posture scanning for cloud using basically CloudTrail. We can do also protection, which is very important, especially in the container. So this is the proactive part. The file security storage that Bharat was telling about, real-time posture monitoring, which again, it's important. We will see what we can do. And then the XDR, because now, yes, everything started with the EDR, so endpoint detection, and XDR now means much more than that. Means endpoints, means servers, means networks, means identity, means email, and now cloud. Yeah, so the XDR now really makes sense in the way that, yeah, it's cross detection and response. So we just launch the stack. Yeah, we need to be authenticated to authenticated to this our AWS, and it's just click create and run. Yeah, so this is how you deploy and you benefit of this cloud infrastructure of the codes type of deploying. Yeah, so no more, I don't know, VMs, no more configuration. Everything is done as a code. Okay, so we deployed that I showed you the example of AWS. We have the same with Azure and Google Cloud. You deploy it, and then you have everything in one picture. And the first benefit that I saw doing a POC with a customer of ours, banking customers, for them it was really interesting to see where their cloud assets were deployed, and they were 100% that everything is in Europe. Yeah, but they were very surprised to see that they have some things running in across the seas, even in Asia. Yeah, so this is a quick win. Yeah, that you get only by deploying this monitoring part. And then you have the inventory. Yeah, if I have inventory for virtual machines, you can check. You have also an associated risk to it. So you see asset type, you see the location, region, and first in, last in. So when was deployed, and when was the last time you see it running. Let's see what kind of info we get out of this in regards with the risk. So we'll go for some of those. So what we do here using this cloud conformity. So it's a product that we checked against best practices. So it's what was the name? AWS best practices, and we do it reactively. So it's not real time. We go and check for configuration. So let's check some of them. For example, this says that the volume attached to this instance, it's unencrypted. Yeah, and you can get here all the details about this. So the recommendation that we do. So first of all, the risk is high because, yeah, you cannot stay with volumes unencrypted. The compliance standards where you breach if you don't do this. So for example, we have here PCI, and then remediation. Yeah, so you get here also the remediation points, either using CloudFormation or using Terraform, or even from the interface. Yeah, you get the steps that you need to do in order to comply with this. And this is just an example. We have, I don't know, 6,000 of this kind of rules that we check upon. So this one, I don't know what this IMDS stands for, but probably it has something to do with again some ISO standards. And yeah, there are a lot of those. Yeah, for example, detail monitoring. And without detail monitoring, basically you will not see what's happening with that machine, because in cloud it's not the way how it works on prem, where you just install, I don't know, a SIEM agent or you collect I don't know, different logs. You have to have everything logged by the monitoring. Then you have the CloudTrail runnings, and then you start from there. This is just an example. And of course, you can say, yes, this one, it's accepted risk for me. And you can just say, change the status to, I don't know, accepted. Yeah. and you put here some reasons for it, and then it will disappear from the recommendation. So it's quite easy. Of course, at the beginning, you'll have lots to do, lots of work in order to go through these checks and accept, or I don't know, go and mitigate them, but then you'll have a good starting point. Then you have the asset graph. Here it's a nice visual representation on what resources are connected or used by this machine. So for example, you see here that this EC2 instance, it's part of this VPC. You can go ahead and maybe add other resources that are connected to the same VPC. So you will see who and with whom is connected. Then you can get the internet gateway. So you can now very easily and in a graphical way. I don't know if you guys have experience with AWS, but it's not that easy always to get this this graphical way of the assets. Yeah. Okay, you have the attached drive, yeah. So the attach disk to it and everything around it. That's the virtual machines, yeah. And then on the same part, you have the clusters, and clusters we can do either local Kubernetes cluster, yeah, or we can very easily get the EKS or ECS from either AWS or Azure. So this can be very easily added in the same console. Functions, so whatever function, Lambda or Azure function you have, data store, and you see here data store, it's about S3, it's about EPS, so the volumes, or what we can see here, let's see if we have any other type of ECR, yeah. This is repository for container, or containers, and that's about it. Yeah. You also have the cloud storage buckets, which is from the GCP. So basically, we put on the same page different names, different technologies from those cloud providers. Even that could be a I don't know, an issue for a CISO or for a security guy to understand all the abbreviations and all the names that the cloud vendors put to these services. Let's see what info we can get out of this S3 bucket. I see that I have quite a high risk score. I just check it to see what's here. I removed, okay, let's see. So non-compliant S3 infrastructure configuration, access control. Most probably it's a public read, yeah, which is totally unacceptable. And then I have another one which is just the remediation for this read access. If I want to go deeply, I remove the filter and I get all the findings. Let's see what we can have, some examples. Yeah. So again, I told you there are 6,000 of those checks we do. Doesn't have S3 block public access rule, again, about the access. Transfer acceleration, which is, again, this part is not security, it's more performance efficiency. So if you enable, and it's very simple to enable this, you'll have 4 times faster transfers between internet and this S3. What examples we can have here? Object is not locked, yeah, and that means that if it's not object lock, then you can very easily rewrite. So you have to have this one stated, and also this is about security. Okay, that's about the data store. The same kind of info we offer for the volumes. Okay, let's see what we have. Just for you to give some examples, maybe this is not encrypted. Yeah, again, this EBS, so this volume is not encrypted. Okay, database. Here we don't have anything in our cloud demo environment, but you can imagine that here you will see all the RDS or the RDBS type of database are deployed in the cloud. The same for identities. Yeah, identity identity checks we do. Again, here is the cloud provider is Google. Let's see what we have here. I didn't check this one. So let's see what we can bring. Okay, so it says here that service account with email is using user management keys for authentication. Yeah, so this is against this practice, including SOC 2, PCI, PCI v4, and so on and so forth. Good. What else I would like to show? It's about file security because Larissa, you were asking how we work with that. So go into the cloud, go with file security, and here you'll see how easy it is to implement. So there are two ways of using this. Either using SDK. So basically, you just take the SDK and implement it in the application logic, which goes and can be used inline. Yeah, so the file will not reach the whatever destination you have, so it can be cloud or on-prem. Or the other way is just scanning the S3 buckets, and this can be real-time scan. So like any anti-malware works like on computers, you connect the S3 buckets, and when the file reaches the bucket, it's scanned, yeah. And if it's good, of course, it's left, and if it's bad, it's just deleted. And here you have all the statistics, yes, and what is the storage to work. As Bharat was saying, is very fast because we don't necessarily go and send out the file to be scanned. It's more the metadata and some info about the file. So it's not a sandbox, yeah. So it's not that kind of product. Yeah, so that's it about the file storage. Again, it's very easy to implement. It's just cloud to cloud. Here is the storage, the bucket, the account ID, and what malware we will find. And the last part, what I wanted to show today is about the container security, because also this container part is becoming more and more important, especially in so-known modern application development, microservices. Either we do it on the cloud, so we can host those containers in AWS using their native orchestrator, or we can do it on-prem. This doesn't really matter to us. It's transparent, so we can do, again, we can do Amazon ECS, we can do Kubernetes, self-manage, yes. So here we have the self-manage, we can do Google, GKA, this is the abbreviation, Microsoft AKS, or Amazon or Azure EKS. And what kind of protection do we offer? First of all, the visibility is key. Yeah, so we just add the cluster and you get all the info. And what kind of info you get? You get, okay, let's find one who has some working notes. I don't know which one was the... one that had some data attached. So no, this one. Okay, this one has, yeah. So you have the, of course, cluster name. You can apply a policy. We will see what kind of policy we can apply. You will see the nodes running. You will see, of course, the pods, yeah, and with all the status of it. Then going deeper in this, for example, working nodes, you will get the image that is running and everything that it's related and its age, running time, and all the stuff. This is the part of the visibility part. But on top of this visibility, you can of course add protection. And protection, it's in two ways. It's it's runtime protection, where we apply using the agent protection in runtime, but it's also build on the build process. So you just go and alter the CI/CD to have also those kind of security checks. And I will show you how you will configure such a policy. You either go and so yeah, this is an example. If you collect all the XDR telemetry, which is also very important when you try to do investigation, and there are here some rules where you set to either lock or log in for different stages. So first is deployment. Then this is continuous, so whenever you update, and runtime. Yeah, so you will have different kind of rules depending on the stage you are. You have the rules, you have compliance, you have vulnerability, which is also very important, especially when using containers, because we all know that the developers tend to use this kind of images. They pull from the internet, and the most popular image, I think, not Apache, but what was the load balancer name? It was basically a very popular stack was containing a miner, yeah, and that was pulled from the internet, deployed, whatever developer were using, and it was containing a miner. That's not a problem. It's not necessarily a malware, but your resources are working for others. Okay, that's it, Larissa, from my side. If there are any questions, I will be happy to take them. Let me. I stopped my camera because I had some issues with internet, and I don't want to interfere.
It's okay. You have a very nice photo. A sketch.
Okay.
Thank you. Thank you for the presentation. Very useful to see also the screens and exactly how the alerts in the configuration review looks like. I wanted maybe to ask you from an operational perspective. The department that would review these within an organization, how would they use them? Would they receive some alerts or have a dashboard that aggregates everything, or would they need to go through the various things to check? Okay, this is the configuration for the let's say the containers. This is the configuration. So in terms of usability for the persons checking.
Usability. So there are let's say 3 actors that might be interested in such a tooling, such a platform. Yeah.
I think your image froze.
He's lost connectivity again.
Can you hear me?
Yes, but I think maybe you should turn off the video.
Yeah, I did turn on, and I went to the office just because I was hoping for a better internet connectivity. Otherwise, I will be from home, and probably it's better. But yeah,
it's like
now you can
Murphy's
hear
Law.
me better. You can hear me now.
Yes.
Yeah.
Okay, so going back. So this platform, it has many actors that can be interested in it. So first and the most value for the SRM, so the attack surface risk management, is for the governments or for the security, not monitoring, but the ones that look at the governments. Yeah, so the checks that you need to fulfill and the policies. Yeah, so that's the main, and there you have, I think, majority of the checks that you will be needed in order to be, you know, on a good security posture for cloud and on-prem stuff. That's the main win I will see in the company. Then you have the SOC guys, yeah, because you'll have the operations, the one that monitors the alerts, and that it's XDR part. Yeah, so what we do there is we have this monitoring of the containers with agents sending telemetry. Then we have also monitoring of the cloud environment, and I told you that cloud, it's a bit different. So we need to use cloud native tools, and there we just take the cloud trail in our platform. And then there we have some detections, some correlations, especially for that, because the volume of the logs, it's huge. Yeah. And then you have the ones that they will go against. You have the DevOps, which will not be liking to be implementing such a tooling because it's a stopper for them. Yeah, so it's an additional check, it's an additional risk, additional basically blocker for them to, you know, to push the updates or the applications. So this are the three main actors that I see. And it has to be a collaboration for all of them. So even those guys need to connect to the platform to understand what's there, because we have recommendation. Yeah. So those are the main ones that I see interested in. Yeah, basically using the platform, not necessarily having emails or alerts. This is where you should be.
Okay, super. Thank you for explaining the different viewpoint and the roles for which the tool can be used.
Sure.
Okay, so I see no further questions in the chat. From CSA Romania, from Cloud Security Alliance, I would like to thank you for your presentation, for your time, and for the insights that you provided. And we will share this on social media and also with the Cloud Security Alliance Global on their website and YouTube channel. And we hope to have a future event on different topics as well and discuss.
Thank you. Thank you very much.
Larissa. Thank you, Bharat.
Thank you,
Thank you,
Mihai.
Bharat. Thank you, Mihai.
Thank you,
Thank you,
Mircea.
everybody. Thanks. Bye.
Bye.
Thank you.
Bye.
Bye.
Have a nice day.
Have a nice day.